Composite functions. A composite function combines two functions to make a new function. Years ago, if I had a dollar bill and I wanted a bag of chips, the first thing that I had to do was take my dollar and find a machine that made change. So I'd input my dollar into the change maker and I would get an output of change. Then I would input my change into the vending machine and I would get my output of my chips. Now what I could do is go to a vending machine with my dollar. I input my dollar into the vending machine and I get an output of chips. That is how a composite function works. It takes two different functions and combines them into one function. In this example, I have three tables. Table 2 has the input-output pairs of G. The function G, you have your number of tickets, N, and then the total cost in dollars, G of N. If I have 2 tickets, that costs $40. If I have 3 tickets, it costs $60. If I have 4 tickets, it costs $80. If I have 5 tickets, it costs $100. Table 3 has input-output pairs of function F. The cost of tickets in dollars is C, and the sales tax in dollars is F of C. So if my tickets cost $40, I have to pay $3.20 in sales tax. If the cost of my tickets is $60, I have to pay $4.80 in sales tax. If my cost is $80, I have to pay $6.40 in sales tax. If the cost of my tickets is $100, I have to pay $8 in sales tax. Table 4, I have the input-output pairs of the composition of F and G. I have the number of tickets and then the sales tax in dollars, F of G of N. So if I have 2 tickets, that gives me $3.20 in tax. If I have 3 tickets, then I have $4.80 in tax. If I have 4 tickets, I have $6.40 in tax. If I have 5 tickets, I have $8 in tax. Our first table has an input of how many tickets you want and an output of how much those tickets will cost. Our second table has an input of the ticket cost and an output of the sales tax. The composite function has an input of how many tickets you want and an output of the sales tax, completely bypassing the cost of the tickets. So just looking at our last table, we see that we have our number of tickets, N. It goes through the function G to give us the total cost of our tickets, G of N. Then G of N goes through our function F as an input to give us an output of the sales tax of F of G of N. I can create a function that bypasses that, where all I have to do is give them the number of tickets. It goes through F of G of N, and I have my sales tax. Composite functions. If F and G are functions, X is the domain of G, and G of X is the domain of F, then we can form the composite function F of G. So you have F and then a circle, G in parentheses, and then X in parentheses. And that means the same as F parentheses, G parentheses, X, close parentheses. We say that F of G is the composite function of F and G. In general, the outputs F of G of A and G of F of A may or may not be equal. In this example, we're going to be using tables to evaluate a composite function. All of the values of functions G and F are shown in Table 11. When x is 0, G of x is 4. When x is 1, G of x is 0. When x is 2, G of x is 3. When x is 3, G of x is 2. When x is 4, G of x is 1. For f of x, when x is 0, f of x is 1. When x is 1, f of x is 3. When x is 2, f of x is 0. When x is 3, f of x is 4. When x is 4, f of x is 2. Find f of g of 0. So another way to write this is f of g of 0. So we start under the g of x equation and we find our 0. So if x is 0, g of x is 4. Then going to the f of x equation, my input x is 4, my output f of x is 2. What that means is that the answer for f of g of 0 is 2. In this example, using the same table, we want to find g of f of 0. That means our input is going to be 0 on our f of x function, which gives me an output of 1. So now I have to find g of 1. So I have 1 under the x, 0 for my output, which means g of f of 0 is equal to 0. In this example, using tables to evaluate a composite function, all of the values of function g and f are shown in table 11. Use a table to describe 5 input-output pairs of f of g. So what we want to do here is take our two functions and combine them to be one function. Since g is on the inside, we know this means I have function f of g of x. So I start with the x for g, find its output, that becomes my x for f, find that output. So I'm starting with 0. If I have an input of x, my g of x is 4. This means I need to find 4 under x for my f of x equation. And if that input is 4, then my output is 2. Next, I start with 1. If my input is 1, my output for g of x is 0. So I find 0 under my inputs for f of x. If that input is 0, the output becomes 1. So when x is 1, the output of g of f of x is 1. Now going to 2, if my input is 2, my output for g of x is 3. So I need to find 3 for an input for f of x. So if I input 3 in my f of x, I get an output of 4. So for an input of 2, my output is 4. For 3, if that's the input, my output for g of x is 2. So I go to 2 under x. If 2 is my input for f of x, the output is 0. So if I have an input of 3, the output for f of g of x is 0. If my input is 4, the output for g of x is 1. Then I find 1 under my x. That becomes the input for my f of x, which gives me an output of 3. So if 4 is my input into my f of g of x equation, then my output is 3. Evaluate composite functions. For each pair of functions, find a, f of g of 2, and find b, g of f of 2. F of x equals negative x plus 6, and g of x equals 5 minus 4x. When starting with part A, what we're looking at is f of g of 2. That means we want to take the g of x equation and substitute x with 2. 5 minus 4 times 2. 4 times 2 is 8, so I have 5 minus 8, and 5 minus 8 is negative 3. Then we want to find f of that answer, negative 3. Have the opposite of negative 3 plus 6. The opposite of negative 3 is a positive 3, and 3 plus 6 is 9. So f of g of 2 equals 9. Now to find part B, g of f of 2. Start with f of 2, which is opposite of 2 plus 6, which means we have a negative 2 plus 6, which is 4. Then I want to substitute that 4 into my g of x equation. So that becomes 5 minus 4 times 4. So that's 5 minus 16. And 5 minus 16 is negative 11. So that means g of f of 2 equals negative 11. So even though we used the same value as our input, 2, f of g of 2 gave us 9, g of f of 2 gave us negative 11. In this example, evaluating a composite function, for each pair of functions, find a, f of g of 2, and b, g of f of 2. For f of x equals 3 parentheses 2 to the x, and g of x equals 3x minus 2. Starting with part A, I have f of g of 2. Starting with my g of x equation, I replace x with 2, which gives us 3 times 2 minus 2. 3 times 2 is 6, and 6 minus 2 is 4. Replacing x in my f of x equation with 4. So I have 3 times 2 to the 4th power. 2 to the 4th power is 16. 3 times 16 is 48. So that tells us that f of g of 2 is 48. Now for part B, we want to find g of f of 2. F of 2 is going to equal 3 times 2 squared. 2 squared is 4. 3 times 4 is 12. Substituting that into the g of x equation, I have g of 12 equals 3 times 12 minus 2, which equals 3 times 12 is 36. 36 minus 2 is 34. So g of f of 2 is equal to 34, while f of g of 2 was equal to 48. This example, I want to find f of x equals x plus 4 and g of x equals 2x. Find an equation f of g. So I'm going to have f of g of x. I'm replacing my x with what g of x equals, which is 2x. So in my equation, I've got x plus 4. So instead of x, I'm going to write 2x and then simplify if possible. So f of g of x is equal to 2x plus 4. For this example, for f of x equals x plus 4 and g of x equals 2x, find the equation of f of g of 3. F of g of x is equal to 2x plus 4 from our previous example. What we want to do is just replace my x with a 3. So I have 2 times 3 plus 4. 2 times 3 is 6. Bring over the plus 4, and 6 plus 4 is 10. F of g of 3 equals 10. In this example, for f of x equals x plus 4 and g of x equals x times 2, find an equation g of f of x. So I have g of f of x, which means I'm going to have g of what f of x equals, which is x plus 4. So I have 2 times x plus 4. 2 times x is 2x. 2 times 4 is 8. G of f of x equals 2x plus 8. G of f of x equals 2x plus 8, so G of f of 3 is going to equal 2 times 3 plus 8. 2 times 3 is 6, and 6 plus 8 is 14. So G of f of 3 is equal to 14. Composite functions. A composite function is a combination of two functions. Using tables to evaluate a composite function, you take the input from one table, find its output. That output becomes your new input, and you find the output for the second table, and that becomes the output for your composite function. When you're evaluating a composite function, you have two choices. You can take the input of your first function, find its output, let that become the input of your second function, find its output, or you can create a composite function by taking the second function and substituting it into the first function to get your composite function. Then you don't have to go through a middle step. Whatever input you have will give you a direct output for the composite function.